All right, our lesson check for today, we're just going to do 3 quick little problems here. So a data set with a mean of 34 and a standard deviation of 2.5 is normally distributed according to the empirical rule. What percent is between 34 and 39? So it might be helpful for you to draw yourself a little curve. So our mean is 34. And our standard deviation is 2.5. So one standard deviation above will be 36.5. 2 standard deviations above is 39. So it wants to know what percent of the data is between 34 and 39. What's interesting here is that's only 1/2 of the 2 standard deviation percentages, right? We normally also have 2 standard deviations below the mean that are all included, and the 2 standard deviations is 95%. So if we're only looking at the right half here, but we know that this entire shaded area is 95%, we'll just do 95 divided by 2 to get 47.5% of our data falls between 34, our mean, and 39, which is 2 standard deviations above the mean. The next one. Keenan scored 80 points on an exam that has a mean score of 77 and a standard deviation of 49. Rachel scored 78 points on an exam with a mean score of 75 and a standard deviation of 3.7. Find Rachel's z-score to the nearest hundredth. So all this stuff about Keenan does not matter. It did not ask us anything about Keenan. It just wants to know about Rachel. So Rachel scored 78 points on an exam. So Rachel's z-score is 78 minus her mean, which is 75, all over her standard deviation, which is 3.7. So 78 minus 75 is 3. Oh, I did divide it by. 78 minus 75 is 3. Divide that answer by 3.7. So Rachel's z-score to the nearest hundredth is 8.1. 8.1. So, 0.81, sorry, 0.81. 8.1 would be a massive z-score. 0.81, 0.81, that makes more sense. She is a less than 1 standard deviation above the mean, but she is still better than the mean. So let's not knock Rachel. She's still good, right? She still did better than average, but she's not like crazy Einstein. She's just a little bit above average. Okay, the problem 3, it says, it is meaningless to compare Keenan and Rachel's scores directly because they took a different exam. Which of the following describes a valid way to use statistics to compare Keenan's score to his exam with Rachel's score on her exam? So we have some options here. Keenan did equally as well as Rachel because each of them scored 3 points above the mean on their exam. Well, we know that's not true because their exam could have been different difficulty. Keenan did better than Rachel because his exam had a greater standard deviation than Rachel's had. That's not true. Rachel did better than Keenan because her z-score was greater than Keenan's. Or Rachel did better than Keenan because the mean for her exam was less than the mean. Nope, that doesn't matter. So we don't even need to determine Keenan's z-score because it's asking us which of the following describes a valid way to use statistics. The way to standardize different data so you can compare it is by using z-scores. So C here would be the answer. Use z-scores, figure out who has the higher z-score, who did better compared to the mean on their respective test, and that will help you determine who did better overall. So that is the end of our notes for section 11.4. I'm going to remind you that you also have a Pearson Realize assignment for 11.4 that you should work on. In addition, you have a statistics project that I will create a video explaining for you. So please click on that statistics project and get started on that. You will have until April 2nd on that project.